Hi everybody, today we're going to talk about parallel lines and proportional parts. So the first thing I want to talk about is what's called the triangle proportionality theorem. So if you have a triangle and then you have a segment within the triangle that is parallel, remember these little arrows mean parallel, to one of the sides of your triangles, you can use this triangle proportionality theorem. So here we know that AE is parallel to BD, so we can actually set up different ratios or proportions within the sides of this triangle. So one that we could set up is we could say AB over BC. So you can see that we took the bottom portion of the left over the top portion of the left, and we could create the proportion that is equal to ED over DC. Now, of course, you could also take both of those and flip. We could also say BC over BA equals DC over DE. As long as you're doing top over bottom, and being consistent, you can always set up that proportion. Now, another proportion we can actually set up is going from left side to right side. So I can say AB over ED, and then I can set up a ratio between the top portions, but I still have to maintain the same order, so I have to go left over right. So BC over DC. And I could also flip both sides of my proportion and set up the ratio ED over AB equals DC over BC. So we have a lot of different ways that we can set up proportions, allowing us to solve for missing sides. So let's give this one a try. First, I'm going to label our figure. So we have EH is 9, HG is 21, FL is 6, and LG is what we're asked to find, so I'm going to call it X. So there's a number of different ways we could go about solving this. We could say 9 over 6, so I can do left over right, equals 21 over X. We could say 9 over 21, so small portion over big portion, equals 6 over X, and I could even flip either one of those upside down. The only thing you cannot do is create a ratio that would say 9 over X. These two do not go together, so that's the only one that you cannot create. But there's lots of different options here, like I said. So let's say that we try to solve that first problem, the first proportion we created. So I'm going to simplify the left side of my equation first. I'm going to divide the numerator and denominator by 3. So we have 3 over 2. And then from there we can cross multiply. So we have 3 times x equals 2 times 21. So 3x equals 42, which means that x will equal 14. And if you set up a different proportion, you would still get that same exact answer. All right, so go ahead and pause the video and give this problem a try. Okay, let's check our work. So you can see I labeled the parts, and then I set up the ratio 4 over 6 equals 18 over x, then I simplified and cross multiplied. Now there are lots of different proportions you could have set up. You could say 6 over x equals 4 over 18. You could say x over 6 equals 18 over 4. You could say 6 over 4 equals x over 18. Any of those should give you the same result, x equals 27. All right, so now we're going to talk about what's called the triangle midsegment theorem, and in order for us to do that, we need to know what a triangle midsegment is. So that is a segment, so such as this, that bisects two sides of your triangle. So if I look at this segment, I can see that it has bisected side CA because the two parts are congruent, and it has bisected side CD, or CE, because the two parts are congruent. So that's what a midsegment does. So if you are told that something is a midsegment, like we're told here, the first thing that you know is that it creates those congruent parts. So we could say that CB is congruent to BA and CD is congruent to DE. But another really interesting thing happens. So it turns out that the length of the midsegment is always exactly the half the length of your base. So we can set up an equation. We would take the base of your triangle and multiply it by 1/2, which is just like dividing it by 2, and that should always be the length of your midsegment. So once again, the length of your midsegment is always going to be exactly half the length of your base. So you multiply your base by 1/2, and that will equal the length of your midsegment. So let's see if we can try that. We are told here that AB is a midsegment. So right off the bat, I'm going to go in and mark these two segments congruent and these two, because that's what a midsegment does. But now we want to solve for x. So I know, once again, the length of the midsegment is half the length of the base. So I'm going to take 1/2 and I'm going to multiply it to the length of the base, which is 34, and that should equal the length of my midsegment. And now I just need to solve. So I have 17 equals 3x minus 1. Add 1 to both sides and divide both sides by 3. We get x equals 6. Now, just to check, if we substitute that value into our equation or our expression, minus 1, we get 18 minus 1, which is 17. And 17 is exactly half the length of 34. So our midsegment is, in fact, half the length of our base. So we know that our answer is correct. Okay, go ahead and pause the video and give this problem a try. All right, so here, since I'm told that MN is a midsegment, I know that this PM is going to be congruent to MQ. That's one of the things that a midsegment does. So I can say 2y plus 6 equals 26, and I can solve for y. Now I also know that with a midsegment, if I take the base and I multiply it by 1/2, which is what I did, it should equal the length of your midsegment. So I have 1/2 times 20x plus 10. Now it's important that you group your base, because here we do need to distribute. So remember, this is just like dividing by 2. 20x divided by 2 is 10x, 5 divided by 2 is 5, and then we can subtract 10x from both sides and divide both sides by 5. X equals 1. Okay, now the last thing we're going to talk about is a scenario where we actually have 3 parallel lines, so like you see here. And we're going to talk about all of the different proportions that we can set up between these segments. So there's a lot of options here. So one thing you can do is we can say like left side over right side equals left side over right side. So we could say AB over BC equals DE over DF. We can go across, so we could say AB over DE equals BC over EF. We can also use our longer segments. So we can use this long segment, AC. So we can say AC over a shorter segment, AB. If I look at the other side, my long segment is DF. And AB matches with DE, so I'd say DE. Or I can do my long segment over my other short segment, so AC over BC should equal DF over EF. So there's lots of different proportions we can set up. And of course, we can take any of these and flip both sides upside down, and it will work just as well. So we're going to use these different proportions to help us find missing parts. So here you can see that they want us to find this length, which I'll call x in our equation. So lots of different things we could set up. We could say 15 over 6 equals 25 over x. So we did this over this equals this over this. Or we could say 15 over 25. So this over this should equal 6 over x. Either way, you should get the same exact answer. So let's solve that second one. I'm going to simplify by dividing by 5. So we get 3 over 5. And then we can cross multiply. So we get 3x equals 5 times 6, which is 30. So x equals 10, which would be the same exact answer as if you solved this proportion. Like I said, there's a lot of different options here with how you set them up. All right, we're going to try one more together. So notice in this problem, we are told a long length, so this 77 is a distance from here to here, and then we're told 2 segments on this side. So if I look at what I'm given, if I create a ratio on the left side, that's x over 7. So x clearly goes with 30. That's the same, the corresponding small segment. But 77 is a long segment. So if I want to create a proportion there, I'm going to need to find the length of this long segment on this side, which we can easily do by adding these 2 up. So I know that that long segment is just 55. So this is the proportion that we can use. Of course, we can say x over 30 equals 77 over 55 as well. You should get the same exact answer. But notice that we did have to, once again, use this long segment. So you have to match up the corresponding parts. So for this problem, let's divide the numerator and denominator by 11. And then we can cross multiply. So we get 5x equals 210. Let's do 210 divided by 5. So we get exactly 42. Okay, go ahead and pause the video here and see if you can solve for x. Okay, so you might have noticed that in order for you to create a proportion using x, you actually have to figure out what this length is. But it's really easy to do. If you know the long length, you could just take that, subtract one of your segments, and you'll have the other segment. So 11 minus 5 is 6. So I used x over 6 equals 22 or 11. But you could have set up a ratio or different proportions, such as x over 22 equals 6 over 11, or even 22 over x equals 11 over 6. Those you should all end up with the same answer of x equals 12. All right, here's the last problem. Go ahead and pause the video and see if you can solve for this value. All right, so here you can see that I created the proportion x over 28 equals 8 over 16. Then I simplified and cross multiplied to solve. But you could have also said x over 8 equals 28 over 16. That would work just as well. There's other proportions that should give you the exact same answer. All right, that is all for today. Thank you for watching.